everyone. Welcome to unit number 6. It is about the containers, Kubernetes, and some of the applications related to cloud. So, the very first topic which we are having, that is container. Now, what is a container? Container is a software which contains the code plus all the dependencies which we require to run a application. Then what is a container image? It is something which is very lightweight and it is executable package which includes all the runtime codes, their systems, libraries, and all the settings which we need to have to run a different software. Then container image gets converted to a container when we actually execute it. Okay, so we have a container image which includes all the softwares, runtime applications, and everything. It converts itself to a container once we are running it on a Docker engine. Now, what is Docker? Docker is actually a provider of containers, which is a company which actually handle number of containers. So it helps you to run your applications. Now, how it actually works. Let us see how the container works. So first of all, we have infrastructure, which includes your hardware. Then we have host operating system. Now we are in containers. We are omitting the use of virtual machines. No, we no longer need virtual machines. Instead of that, we are having a single host operating system on which a Docker will be installed, and that Docker engine. This is the Docker engine actually, and above it we are having different applications which are your container images. Now once you want to run a particular image, you run it with the help of a Docker engine. Now every application is a isolated application from the other one. So application A is not having any relation with application B, so all of them are independent of each other. But application A is a complete application along with its own dependencies and everything. So you need not to have any type of special OS required to run the application A. In containers, the host operating system is shared among all the different applications, which makes it very lightweight. If we compare the same process with virtual machines, so we will need multiple number of operating systems to run different applications. So in this case, if we are having 6 different applications running, so we need to have six operating systems to run those applications, which makes it a bit heavyweight work, or heavy of lifting is required to run such kind of a setup. Whereas if we are using containers, what we are going to have, instead of having 6 different host operating systems or guest operating systems, we can work with a single host operating system, and it will be shared among all the different applications which we are having. Let us move to the next. Now, how this Docker architecture is working. Now we have Docker registry. Now in Docker registry, there are some images which are present. There is Ubuntu. We have some other type of controls. We have nginx. So it is up to you whatsoever. If you want to run your own image, means if I want to run Windows 10, I will need to include it inside this registry. Now, how to do that? We will be doing it in your lab classes. So, how to upload your image into a registry. So, we will talk about that. Then we have a Docker host. Or in this Docker host, what we have a Docker daemon. Now, Docker daemon's work is to take the instructions from client. Now, what is the work of client? Generally, this client and the Docker host are installed on a single system. But if you want to work on remote basis, means your Docker is installed on a separate software which is located at a far place, and you are sitting at some other place and you want to run that containers, what we will do is we connect this client with this Docker host by using protocols such as your REST and SOAP protocols. So they will interact with each other. Now, whatsoever commands you want to run, you will be running it on client. So Docker build, Docker pull, Docker run. So these are some of the commands which you use to run your containers on your Docker platform or with the help of Docker daemon. So what happens if the Docker daemon is able to find out the app image present locally? If that image which you want to run is present on that system, it will run it directly and convert that image to a container, and it will start executing it. Now, if it is not present, what will happen? It will check the registry and pull that image from registry and then start running it. Okay? So if the image is present locally, done, it will directly execute it. If it is not present, it will have to pull it from the registry. So let us talk about the different things which we have in this, like Docker host, client, and registry. So the Docker daemon listens to Docker API requests and manages Docker objects such as images, containers, networks, and volumes. So everything is stored at this place. Then Docker client, its main task is to interact with the user and get the commands from the user. Once the user is given the commands, if they both Docker host and client are located on a single system, it is fine. If they are at different places, they will be able to interact with API. Okay. Now, and one more thing. See this. The Docker client can communicate with more than one daemon. So it is not required that we need to have only a single client interacting with a single Docker daemon. So there might be multiple number of Docker daemons with which a single client or Docker client can interact. Then is registry. So it is placed at this place. This is the registry in which the images are stored. So it stores the Docker images. Docker Hub is a public registry. Now public registry means where you are going to store your own images which you want to run. And Docker is configured to look for images on Docker Hub by default. Now what does it mean? If you are trying to run some of the image and that image is not present locally, so what will be the first place on which Docker will try to find out that image? That is registry, Docker registry. If it is present in the Docker registry, Docker will pull that image from that place and starts executing it. So firstly it will need to download that. Now if you are having a application or you are having the OS which you want to run present inside the registry, it is well and good. If it is not there and you want to do it for yourself, you have made some changes in the OS and it is your own OS which you want to run, then you need to upload it on that registry. Then we have next, that is Docker objects. When you use Docker, you are creating and using images, containers, networks, volumes, plugins, and other objects. This is the brief overview of those objects. So what is a Docker object? So all those things which you are going to use inside your Docker will include in your Docker objects. The first thing which we are talking about is a image and a container. So image is a read-only template with the instructions for creating Docker container. Often an image is based on another image with the additional customization. Now, what does it mean? Generally, what we do, all these images which we are having, they are related to some OS or some additional features which you are going to include in an image or in the OS. So you include those all images at this place. Now, once you want to run that image, you need to shift that image to a container. Now, a container is a runnable instance of an image. Means whenever your image is running, now image is not a photograph. Image at this place is your like Windows ISO file. That will be a image. Okay, you can create, start, stop, move, or delete a container using Docker API or CLI. API, you are aware what is this? Application Programming Interface. CLI is command line interface. So generally we can work with CLI and API both to interact with the container. So you can connect it with the container, you can attach it with the new networks, whatever you want to, you can do that. Now, how this actually works. So let us see this. This is Docker daemon, which is actually running, which is a server. How to interact with it with the use of REST API. If both of the systems are both your client and Docker daemon are on the same place, on the same system, it is fine. If they are not, they can interact with REST API. Then we are having client Docker CLI, which is Docker's CLI interface, which you need to access. Now, what we can manage from this, we can manage networks, we can manage data volumes, we can manage images, we can manage containers. So all these things can be managed by using Docker's client CLI interface, that is command line interface. So generally what you can get from this is most of the work which you are going to do on Docker will be using command line interface only. This is about your Docker. Now, the next topic which we are having, that is Kubernetes. Now, what is it? Kubernetes is also known as K8. It is used to automate the process of Docker, you can say Docker execution. So what you are going to do in this is it will automatically, it can scale your applications, it can manage all the containerized application automatically. You need not to have any kind of human intervention in it. Okay, so containerization helps package softwares to serve these goals, enabling applications to be released and updated in a easy and fast way. So you are not going to have a downtime in this. Kubernetes was developed by Google, but now it is sent to a open source resource. So anyone will be able to use it. Google is no longer controlling the Kubernetes. So there are some of the objects which are there in Kubernetes, so we should be aware about them. First one is a pod. Now, what is pod? Pod is a collection of different containers running at a single place. Okay, it is a group of containerized containerized components, which means number of containers are running on a single place is known as a pod. All the containers which are inside a single pod will be able to interact with each other, but one container in one application or in one pod will not be able to interact with another pod which is in another an, another pod which is in another container which is in another pod, so it will not be able to interact. Let me elaborate it again once. One container which is inside one pod will be able to interact with the other containers in the same pod, but one container which is in one pod will not be able to interact with the another container in another pod. Okay, so it is also explained at this place. Each pod in the Kubernetes is assigned a unique pod ID address within the cluster, which allows applications to use ports without the risk of conflict. Within a pod, all containers can reference each other, means they can interact with each other on the local host, but a container within one pod has no way of directly addressing another container within another pod. So it means they will not be able to interact if they are part of a separate pod. So they give you a pod ID. So pod IP is required, which will be used as your pod IP. Then next is replica sets. Now the replica set purpose is to maintain stable state set of replica pods running at a given time. Now what is the requirement of this? If we want primary and secondary stuff, means I need to have a backup present, and then I will need to create replica sets for that. It is a grouping mechanism that helps the Kubernetes to maintain the number of instances that have been declared for a given pod. Now, what happens in this is whenever you are working with pods are having number of containers in them, which can be 4, 6, 8. So it is 4, 6 up to 6. I think the maximum limit is there. So you need to create some replicas of it. Now, why it is required? If one pod or one container fails, you will be able to pick it from the second one. And one more interesting thing about the containers is the containers only work till the time you are executing. Once you no longer need the container, it will get destroyed. So this is how it works and why we call it as lightweight. Okay. Now the next thing is services. Now, why we need services? It is to just maintain the networking between different pods and how they are going to interact with each other, what will be their domain name, services, everything is included in your services. Generally, services include the networking tasks. Next is volume. Now, why do we need a volume? Volume is to store the data which is being executed by a pod. Because once your Docker is no longer needed, it will destroy. It will get destroyed. So if it is getting destroyed, you need to store the data which it has executed. How you are going to store it? You will be storing it in the volumes. So file system in the Kubernetes contain provide ephemeral storage by default. This means that a restart of the pod will wipe out any data on such container. Means whatsoever data you are having will go away once you turn it off. This forms a this form of storage is quite limiting in anything but trivial applications. A Kubernetes volume provides persistent storage that can exist for lifetime of a pod itself. Means once you destroy the container, its whole data will be gone, but you need to have a volume. Now in that volume, you will be storing the data and that data will be kept as it is till the lifetime of the pod. So this is about Kubernetes and containers. So we will start with the next topic in the next lecture, which is about exploring the cloud applications. So we'll do it in the next lecture. Till now, if you have any queries, please do ask me on your LPU Live app. Thank you.